This is the video about least count multiples, okay? And using factors, we'll compute LCM using factors. Okay, let's continue. This is the video number 20, part 2 of 4. I have divided the video in 4 parts, and this is the second part. Let's continue. Okay, now we'll talk about how to compute LCM using factors. Okay, so let's compute LCM using factors. Okay, question: what are we looking for here? We're looking for least common multiple. We'll use divide and conquer again, and this method is we do factors, identify factors common to all the numbers, multiply all common factors, and this is my HCF. Okay, so far we have done that in the previous video. Okay, identify factors common to fewer than all, multiply this HCF number with these common factors, okay? Multiply with any remaining factors which is common to only one. Okay, and note, literature might suggest that use prime factor. We will just go ahead and use the factors we can think of and then convert these to prime factors. Now we'll compute LCM example. Example is from an online PowerPoint presentation. Okay, so what's HCF of 8 and 12? Okay, let's find out. We are going to do the factors here. Are both numbers even? Yes. We're trying to find out what's common factor here. 2 is a common factor, so that means that the two numbers are 8 is 2 times 4 and 12 is 2 times 6. So 2 is a common factor here. Are 4 and 6 both even again? Yep. So yes, and 2 is factor again. So 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. Okay. Now these 2 and 2 are common factors, and these 2 and 3. Let's continue here. So 8 is 2 times 2 times 2, and 2 times 2. 12 is 2 times 2 times 3, and 2 and 3 don't have any more common factors. Okay. So do 2 and 3 have any common factors? These two, number 2 and number 3 here? Nope. Okay, so HCF is 2 times 2, this common factor, and LCM is 2 times 2 times this 2 and this 3, which are not common factors. Okay? So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. Let's continue. We use product of all common and not so common factors to find the least common multiple. Let's continue from here. Example continued. So this is another example here. Okay, it's a radio station gave away a $100 bill for every 100th caller, and every 30th caller received free concert tickets too. How many callers must get through before one of them receives both a $100 bill and a concert tickets? Okay, let's continue here. Here we're looking for the first, which least number caller who receives both a $100 bill and concert tickets. So first thing we're looking for, are there any common factors in 130? Okay, so we're looking for LCM of 130, and we know that we need to get all the factors, common and not so common factors. Okay? Yes, 10 is a common factor. Okay, let's continue here. So 100 is equal to 10 times 10, and 30 is equal to 10 times 3. Okay? So this is my common factor, and this is my not so common factors, 10 and 3. Okay? Let's continue here. So HCF is 10. HCF, this is my common factor. There are no more common factors here. 10 and 3, I don't have a common factor. Okay, and no, not so common factors are this 10 and this number 3. Okay, let's continue here. LCM is HCF, which is 10 times the not so common factor, 10 and a 3. 10 and a 3. Okay, which is equal to 10 times 10 times 3, which is equal to 300. So 300th caller would receive both a $100 bill and do another example here. This time we will do LCM of 70 and 90. Let's continue here. What's the LCM of 70 and 90? We'll use the list method here. So we'll make a list of multiples of 72 on the left side and those of 90 on the right side. Okay. So we get 72 times 1 is 72. 72 times 2 is 144. 72 times 3 is 216. And of 4, 288. 5, 360. And 6, 432. And so on. Okay. Let's do multiples, a few multiples of 90 and see if there is any match. Okay. 90 times 1 is 90. 90 times 2 is 180. 90 times 3 is 270. 90 times 4 is 360. At this time there is a match. 360 is a multiple of 90 and 360 is a multiple of 72, and this is the first or least multiple we found so far. Okay, so this is our answer. Let's continue here. So 9 times 4 is 5 is 450. Okay, we don't need to go that far, but that's okay. Let's continue. And then we have 90 times 6 to 540 to see that this is the only matching multiple so far we got. Okay, and this is the least one. This is the first one. We say 1 2 3 4 5. We use the smallest multipliers here, smallest multipliers here. So very first least common multiple is 360. Okay, that means LCM is 360. LCM of 72 and 90 is 360. Compute LCM of 275, 675 and 950. The same numbers we had used before in computing HCF. Okay, let's continue here. What's LCM of 225, 675 and 950? Okay. But do you notice any common factors? We know that 25 is a common factor because this first number ends in 25, second number ends in 75, which is multiple of 25, and third number ends in 50, which is also multiple of 25. Let's continue here. Yes, that's a 25 is the common factor. Okay. So the numbers are 25 times 9, 25 times 27, and 25 times 38. If you need some time, please think about it, and you can verify that that's true. That these 225 is 25 times 9, 675 is 25 times 27, and 950 is 25 times 38. Let's continue. Do you notice any other common factors? Okay, 9, 27 and 38. Okay, 9 and 27 have a common factor 9, and 38 does not have the same common factor. Okay, not all common to all, but however 9 is a common factor of the first number 9 and 27. Let's continue here. So numbers are 25 is a common factor to all, and 9 is a common factor to two numbers. Okay, now we have numbers 3 and 38. Okay, those are odd numbers so far. Okay, so are the common factors of 3 and 38? Nope, they're no common factor. They're not both even. They're not both divisible by 3. Okay, let's continue. HCF is 25. That's the common to all the factors in all the number 25. Okay? And LCM is 25 plus factor common to 2, 9, and factor not common to only one number 3 and 38. So that would be equal to 675. 25 times 9 is that number 225, times 3 is 675, like that. 225 times 3 is 675, and times 38. So we'll do that. 38 is 40 minus 2, and we will do a 2 times 20 minus 1. 38 is 2 times 19, which 2 times 20 minus 1. We'll do that. Try to figure out a easy, simpler way to multiply. Okay, so that is equal to 675 times 2 is 1350. We have done a video on doublings, and times 20 minus 1, 27,000, which is equal to minus 1350, and which is equal to 25,650. We have done all from 9 and last from 10 type 2 subtractions before. Okay, so LCM is 25 times 9 times 3 times 38, and which Okay, let's go LCM of 1350. Okay. A teacher teaches two classes, and one has 30 students and the other has 50 students. What's the minimum number of pencils the teacher needs to carry to distribute evenly to either class? If a class of 30 shows up, teacher should be able to pass out the pencils in evenly distribute them. If the class of 50 shows up, he should have no issue in distributing the pencils evenly to all the classes. Okay, let's continue all the students. Let's continue here. So we are looking for LCM of the least smallest number of pencils, minimum. Okay, least LCM is 30 or 50. That's what we are looking for. Okay, let's continue. Do you see any common factors of 13, 15? Sure, we have see 10. Yes, it is 10. Let's continue here. So the numbers are two numbers are 10 times 3 and 10 times 5. 30 is equal to first number is 10 times 3. Second number is 10 times 5. Let's continue here. Do you see any more common factors 3 and 5? Nope. There are no more common factors. This 3 is divisible of 3 and 5 is not divisible of 5 and 5 is divisible of 5 and not by 3. Let's continue. So HCF is 10. That's a common to both numbers, and LCM is HCF, which is 10 times not so common factors 3 times 5. 10 times 3 times 5 is 150. So LCM is 360, 150. LCM of 30 and 50 is 150. Let's continue here. Teacher needs to carry 150 pencils. So we're looking for how many pencils the teacher needs. So if the teacher has 150 pencils, he might face a class of 30 students or the class of 50 students. She will be able to distribute the pencils. Now we have done HCF of these two numbers before. Now we will do LCM of these numbers. 142, 857 and 9999. Okay, let's continue here. What's LCM of, well, this equation 142, 857 and 999999. Okay, let's continue. Do you notice anything special about first number 142, 857? The two parts of 142 and 857 are 142 plus the two parts are 142 and 857, such that 142 plus 857 is 999. Okay, so and that must be, it means that it is equal to 143 times 9999. That number must have come from multiplication by a sequence of nines. Okay, let's continue. And we discussed that in this video, multiplication by sequence of nines, and the video is that one. Okay, let's continue. Do you see anything special about this number 999999? That sequence of nines first, another sequence of nines again, three nines and three nines. Okay, first three digits and last three digits match. Okay, the two parts are 999 and 999. The two parts are equal. Okay, the two parts match, we just said. Okay, let's continue. And let's look at how do we get two matching parts. If I say 11 times 3, I get 3 and 3. If I 101 times 67, I got 67, 67. That is a sequence of zeros guarded by two ones at the end, one on the left and one on the right. So 1001 times 253 is 253, 253. That's two zeros being guarded by one single digit 1 on left and single digit 1 on the left, right. Okay, let's continue. That means 999 and 999 is equal to 1001 times 999. That, what does it mean? 999 is a common factor here. Okay? Okay. The two numbers are 143 times 999 and 1001 times 999. Okay. So 99. Okay. So we already computed so far. Let's continue here. Do you see any common factors of 143 and 1001? Okay, let's continue here. Both are divisible by 11. This is divisible by 143 is and 1001 is. And this is the video we have. Divisibility by remainders. We did that, and it talks about some difference method here. Digit sum and digit differences. Okay. Let's talk about numbers are. So the two numbers are now 11 times 13. 143 is 11 times 13, and 1001 is 11 times 91. Okay. So we have a 11 is a common factor, 999 is a common factor, and this 13 and 91 we have to resolve further. Do 13 19 have a common factor? Both are divisible by 13 because 91 is equal to 13 times 7. Let's continue here. The numbers are 11 times 13 times 999, 11 times 13 times 999, and times 7. 11, 13, and 999 are common factors to both the number, and 7 is not the common factor. Let's continue. So far we have done that. So now there are no common factors. We have to multiply by all the common factors and not so common factors. So the HCF is the common factor 11 times 13 times 999, which is equal to 142857. That's my HCF here. Okay, and then let's LCM is HCF time product of not so common factor. Not so common factor is this number 7, which is not in this the first one. Okay. Multiply by 1 does not make a difference to the results. Okay, let's continue here. So LCM is 142 times 857 times 7. Okay, and you can multiply them together, and that's 999,999. That's the second number here. So HCF is the first number of, and in this example, and LCM. Let's see if we need to do a prime factors. Okay, let's continue. What's the LCM of 142,857 and 999,999? Okay, we already did that. The two numbers were 143 times 999, and this one was 1001 times 999, and which we further divide into 11 times 13 times 999. This 11 times 13 times 7 times 999. Okay. Now, but we are caring for a prime factors here. Instead of doing the factors, we did 999 as common factor here, which is not a prime. So that's what we do. If you really care for prime factor, we can continue from here. So 11 times 13, 999 is 9 times 111, and 9 times 999 is 9 times 111. I move the 7 to the right, which is not common. These two are, I just move the common factors to the beginning here. Okay, let's continue here. So 11 times 13, 9 is 3 times 3, and 111 is 3 times 27. And this is 11. Now the 7 here, 11 times 13 times 3 times 3, 4, 9, and 3 times 37. Okay, let's continue here. HCF is this common factor here other than 7. This is 11 times 13 times 3 times 3 times 3 times 37, and which is 143 times 9 times 111, which is equal to 143 times 999, which is equal to 142857. Okay, now LCM. LCM is HCF times not so common factors, and not so common factors, only one factor is not so common, which is 7. Okay, let's continue here. So 142857 times 7, okay, and which is equal to 999,999. And that is my second number. HCF of these two numbers is the first number 142857, and LCM of these two numbers is second number, which is 999,999. Let us continue. Now look, LCM of 27 and 99, 999. LCM of 27 and 999. Let's continue here. What's LCM of 27 and 999? Let's continue. Do you see any common factors? 2, 3, like 2, 3, 5, 7, 9, 11, which we know how to figure out. Okay. 9 is common factor of both the numbers because the digit sum of this 227 is 9, and digit sum of 9 is also 9. The 9 is a common factor. Okay. That means first number is 9 times 3 and second number is 9 times 111. Let's continue here. Do these numbers have 3 and 11 have 111 have any common factors? Yes, digit sum of both is 3. 3 digit sum is 3 and 1 plus 1 plus 1 is 3. They both are divisible by 3. Let's continue here. So the numbers are 9 times 3. First number is 9 times 3 and second number is 9 times 3 times 37. So 9 is a common factor to both, 3 is a common factor to both, and 37 is a factor only of the second number. Let's continue here. Do you see any more common factors? Okay. Nope, there are no common factors. So HCF is the common factor, uh, product of the common factors to both the numbers. 9 times 3, 9 and 3 and it's 27. LCM is equal to HCF, which is 27 times not so common factor. 37 is a factor of only the second number, not of the first number. Not so common factor, which is it. So that's 27 times 37. 27 here and 37 that not so common factor. Okay. So which is, and 27 times 37 is like 9 times 111. Okay. We just split the 27 is 9 times 3 and 3 we multiply with 37. Okay, and which is equal to 999. In Vedic math, we try to figure out any way we can simplify the problem. Here, I know that 3 times 37 is 111, and I split that 27 into 9 times 3. Okay, so we say 999. Let's continue. Another LCM example. Linda and Paul are cycling around a track. Linda completes one track in 15 minutes and Paula in 10 minutes. Both started at 8:30 a.m. from the start point in the same direction. They're both running in the same direction. When would they meet next at the start point? Let's continue here. What are we looking for? We're looking for next earliest time. Okay. How do they meet at start point? So if they start and how do they come back to start point here? Okay. Answer by completing whole tracks. After each completing whole track, they are at a start point. Okay, so Linda's at start point. One is the Linda at start points. Okay, one is Paula at start point. We'll make a list of the when these two girls, Linda and Paula, are at the start points. Okay. Linda is start point 8:30 plus 0 minute. That's where start point is. That's where the first, they both take off. Okay. And Paula is also at same time 8:30. That's what the problem says. They meet at both start 8:30 a.m. from the start point in the same direction. Okay, let's continue. Okay, so Linda takes 15 minutes to, so Linda would be there 15 minutes after also. Okay, and Paula would be there at 10 minutes after. Okay, now 15 minutes was more than 10 minutes, so we discover one more number here. So Paula would be there at 20 minutes after 8:30 also. Okay, let's continue. And Linda would be there in 30 minutes. In second, completes one round at 15 minutes, completes another round, another 15 minutes. That's 30 minutes. Okay. So now we look at where the Paula is. Okay, and Paula goes through the round here and gets 30 minutes. In the next, it completes one more round and gets back start point at 30 minutes. Now 30 minutes matches here and 30 minutes matches here. Okay, let's continue here. Do you see both this at start point at the same time again? Yep. That is 8:30 a.m. plus 30 minutes. 8:30 a.m. plus 30 minutes. 8:30 a.m. plus 30 minutes. Okay. Okay. The two meet at start point next at 9 a.m. 8:30 a.m. plus 30 minutes is 9 a.m. Okay. Let's continue. Okay. Let's just do some problems. Okay. For the LCM of the following problems, okay, LCM of 72 and 111, 12, 143 and 110, 15, 30 and 105, 63 and 27 and some more. First is We use that Bharti Krishna's book is the main reference to anything we do in Vedic math. The next is Discover Vedic Math by Ken Williams. This is most complete, authoritative, and consistent notations. The only thing is it's organized by sutras and not by the topics. Okay. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. They're easy to use, easy to read, very complete, contain significant geometry which I have not covered. Let's continue here. And also mentioned figuring by book Figuring by Shakuntala Devi. Let's continue.